Okay, so in this section, we'll be using the z-scores to help us out. So let's define that first. The z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. Number of standard deviations. Population z-score. So basically, to find it, you use this formula. If you're dealing with population, you're going to use x minus mu over sigma. Sample z-score. It'll be the same thing, but use the appropriate formulas and symbols. So capital Z would equal X value in question minus X bar, the mean, over lowercase s, standard deviation. So no matter what, so if you want to convert an X value to a Z-score, you plug in the X here, some data point, right? X is the data point, minus the average, everything divided by standard deviation. So it's the same formula. It's just in the population, you use the other formulas for standard deviation and mean. Okay. Now you can manipulate the formula, solve for X or something else. I don't know if it'll come up, but just in case. If I solve for X, you agree that this would be X equal to Z times sigma plus mu, right? Just isolate X, it's using algebra. Isolate X here, you should have the same thing. X would be equal to Z times S plus X bar. And you can solve them all if you really want to, but the only thing I can think of that they might ask about is convert to Z or convert to X. Just in case, there it is. And we'll do some examples in a second. Okay. So this is basic baseball example in the book. Determine. I'm going to shorten it up because they mentioned a bunch of stuff I don't care about. Let's get straight to the point. So determine if Boston or LA had more had a relatively better run season, run producing season. In other words, more home runs, more scores, right? More points, whatever. I don't really care. So you're gonna need the averages and standard deviations for each team. You're gonna change both of those averages into z-scores or values. Then you can figure out, okay, which one's higher? That's it. Just calculate. So what they're gonna give us for, I'm gonna summarize this a little better. Boston had an average where is it? Average runs equal to 731.2. Standard deviation of 72.6. These are runs. Home runs. Okay. LA had average runs of 710.8 and a standard deviation of 60.2. Boston scored 876. And they play in the American League. LA scored 804 runs, and they play in the National League. So it's just for like some random year. Okay. So based on that year, which team produces more runs? But relatively. So I know this year Boston had more, right? I know that Boston averaged more than LA did. But look at the standard deviation, right? So this LA varies less than Boston. We'll have to check the z-score and determine, okay, who's more consistent, who actually produces the most. So just calculate z. So z for Boston, it's going to call it capital B. That's going to be 876 minus 7, so the mu, right? 731.2 over 76.6. ZL will be 804 minus 710.8. over 60.2. So roughly, what is that? I don't know. I don't know what that is. About you guys get 1.99 for the first one? $1.55, second one. So who had the better year, Boston or LA? So we had the scores for both years, or for both teams that year. We had the general overall average, getting all data in for every single year since it started. Deviations for both teams as well. This one's higher, so relatively speaking, Boston did better that year. So looking at that particular year, Boston did better. So we're converting that year's score here into these. That's all we're doing. Boston had a better year. Okay. Any question on that? Do you see what the Z means based on the definition and the application? All right. Let's talk about percentiles then. I'll turn the page in just a moment. You guys know what percentiles are? If I told you your height is in the 90th percentile, what does that mean? Yeah, you're for sure in the top 10%, right? So in other words, 90% of the population is below your height if you're in the 90th. So that you're at the top, basically. Same thing for like exam scores, GPAs. If you're in the 99th, then you're 99th of everyone else is below you. Okay. So let's write that definition down, the official definition, but basically what it means in plain English. But the book's definition is this: the kth percentile denoted P sub K. So if they have like P90, that means the 90th percentile. Okay. Of a set of data is a value such that kth percent of the observation are less than or equal to the value. basically what we just said, right? Just more proper, I guess. Let's say, I don't know, here's a random example. Jennifer received the results of her SAT exams. Her math SAT score is 600. Her score is in the 74th percentile. What does this mean? So it's just about interpretation, that's all. Not really a calculation problem, just. So anyone above. How should I phrase it? How many more percents are above her score 600? There's 26% of the population above her. So that means anyone who scores above 600 was with this in that group, right? So 74% would be below 600. So a huge chunk of the population is below 600 on the SAT score. Okay, does that interpretation make sense? Okay. So the only reason we mention percentiles is because it leads into quartiles. It's the same stuff. It's just quartiles are the 25th, the 50th, and 75th. So you will be asked to find them. So let me change gear here. Finding percentile or quartiles. So this is how you find them. So step one, arrange your data in ascending order. Step two, determine the median. Median is also the second quartile. So if you see Q2, that is median. If you want to find Q2, just find the median first. So first step is put the data in order. Step two, find that median. You got Q2. Step three. Divide the data into halves. The observations below M or Q2 and the observations above M or Q2. So you just cut the data into two halves. Above M2, sorry, below Q2, above Q2. So once you've done that, the first quartile will be the median of that bottom half. So just find the median again for that chunk. Then find the median for the top for Q3. That's it. Q1, the first quartile, is the median of the lower half. Q3 Q3, the third quartile, is the median of the upper half. But you can use use your calculator, Excel, StatCrunch. They'll find Q1, Q2, Q3 automatically. Okay, and then that's fine. Let me go ahead and show you how to do this. I'm running out of time, actually. Example 2. Given data, find Q1, Q2, Q3. Here is the data they're giving us. 6751. These are all dollar amounts. 189. 10,034. 9908. 1185. 735. 3461. 370. 802. 2336. 1414. 618. I still got a ton more. Okay. 21,147. 4,668. 180. All right. 2332. 1953. 1657. All right. My hand hurts now. All right, so step 1 is put them in order. It's the first thing we got to do. And then cut it in half, half being the midpoint. So just open Excel and type these in. That we can just have it prettier because these look kind of. It'll be easier to sort in Excel. But we're still gonna do it by hand. Does that make sense? Just so you can see how to do it. Then I'll show you how to do it on there. Yes. Okay, so open up Excel, please. Just type those in. Okay. Let me share that screen with you. Give me a second. Need to share it here so it shows up on the recording. There we go. Can you guys see these numbers? And try to zoom in for you. Let's see. Let's see. Maybe that's too zoomed. Anyway. Highlight your data. After you've typed them in. I believe there's 1, 2, 3, 4, 5, 6. 1, 2. Should be 18 data points. Might be easier if I did this. Okay, if you right click, there should be a sort button. Smallest to largest or largest to smallest. Ascending would be step 1. Smallest to largest. I think it's really annoying trying to do that by hand, putting them in order. So just right click and sort. Once you have them, you can calculate the median, no problem, right? We said if it's even, there was a rule. Two, 3, 4, 5, 6, 7, 8. So zoom out just a little bit. You want to just go ahead and find it over here. I'm running out of time. So type median somewhere. Hit equals. You should have a median function. Double click that button or that function. Now I want you to highlight some data points. So highlight yours 18 points. Hit enter. Median is 1805. Do we have an 1805? No, right? So that means that because it is even, because we have an even number of data points, you take the center 2 and you add them up and divide it by 2. You average them. The average of the center 2 you need 1805. Okay. So that is also Q1 or Q2. better this way. Okay. Excel go. Okay. That's to extend, yeah, so be. One moment. Sorry, I'm just having some issues there. Okay. So we're gonna cut it in half. Below Q2. All right, so let me make a note right here. Median is equal to 16, if you were to do this by hand, 1657 plus 1953 divided by 2. So that's where the 1805 came from that Excel gave us. But I use Excel because the sorting is awesome. I don't want to sort by hand. Okay. Now that we have that, the bottom half is going to be everything below 1657, including 1657. So cut the bottom part in half, so the data in half. So these are just coming from here, but they're in order all the way up until the 1657. So the median is right here. So this is Q1, sorry, Q1. So the median of the lower half below here, starting here, Q1. So now do the top half, running out of space. Everything above 1657. So you can just write down everything from the Excel if you want. That might be easier to read. But I'll write it down right here. So starting at 1953. That's all the top half. 9908, 10,034, 21,147. Okay, so the median of the top half is this guy. So this is Q3. There's 1, 2, 3, 4 data points on either side. So that is the exact center. Same thing over here. Of course, you can, what you could do, right? Once you identify the center 2 points, just highlight from here below, right? It's fine too. You want to do this on Excel? No, wait a second. Sorry. So far, you guys okay? All right. So let me know. So what you can do to get Q1 by via Excel. You can do median formula, which is high all the way up until 1657. Right, we found 735, correct? Q3. Median. Everything below, what number is it? 19? Right? Yeah, okay. Is that what we got? Was Q3 4668? Okay. Now, I'm low on time, but we'll probably have to talk about this some more next time. Something else that you could have done is do a box plot to get all this at the same time. Okay. Could have. If you go to data, you should be able to do a box plot in here. We'll have to say that for next time. Let me take roll. I'm sorry. I'm being overly ambitious. We'll take our time. We'll talk about it some more Wednesday. Okay. But if you have any questions, please stick around after I take roll. Dylan, Isaac Beal, yeah. Sonia, Jalen, Bianca, Christabel, Antonio, Elizabeth, Amanda, Kaylee is not here, Addison, Caitlin, Clarissa, Sebastian, Abigail, Giselle, Aaliyah, no Aaliyah, Mariana, Jennifer, Emma. All right. You guys have any questions about quartiles or percentiles? Better stick around. If not, I'll see you Wednesday.